Here is one more very interesting problem on projectile motion. Let us read it first. A projectile of mass 2 kg has velocities 3 and 4 meters per second at 2 points during its flight in a uniform gravitational field of the earth. If these two velocities are perpendicular to each other, then the minimum kinetic energy of the particle during its flight is. Let me again warn you here that when he asks you the minimum kinetic energy, please don't feel that it is going to be 0. Of course, there is no option here as 0, but had he given one option as 0, I think it would have been a dangerous problem. Because in the one-dimensional motion, especially when you had projected the particle vertically upwards, you were always having this particular feeling that when the particle reaches the highest point, the velocity of the particle is going to become 0. And you are correct, no doubt. But now, because it is a projectile motion, the particle, after having reached the highest point, will have its only vertical velocity equal to 0. The horizontal velocity of the particle is still associated with the particle. Vertical velocity has become 0. So, the minimum kinetic energy of the particle at the highest point of its trajectory will be corresponding to the horizontal velocity that the particle has. Fine? Okay, that is one thing which you have to remember, and let us also use the data that he has given. So, I will draw a figure there for you people. So, this is, you can say, the projectile motion. Let us refer to one of the points here and the velocity to be, say, 3 meters per second, and the angle that it makes with the horizontal at that instant be alpha. And let us consider the other velocity to be when the particle is here, and this velocity is 4 meters per second, and the angle that it makes at that instant will be actually beta. But because he has said that the two velocities are perpendicular to each other, see, velocities are perpendicular to each other, let me extend this and try to check what relation is there between the angle made by this velocity with the horizontal and the angle made by this velocity with the horizontal. Or else, I would have certainly taken the angle made by this velocity with the horizontal to be something different. If the angle made by the previous velocity with the horizontal was alpha, the angle made by this velocity with the horizontal would have been beta, because the velocity continuously keeps on changing. Its direction changes, its magnitude changes, and there is a continuous change, right? But because he says both these velocities are perpendicular to each other, let us use a little bit of geometry and try to see the relation between the two angles. So, I am going to extend this backwards like this. So, if you extend this one, this angle is given to be 90. So, if this is alpha, then this is 90. So, 1 second, what is going to be this angle? Oh, fine. So, if I just imagine one horizontal line here, then this angle is alpha. So, this should be 90 minus alpha. Fine. So, I hope it is clear. See, this is the velocity initially, which I have extended further, and I have drawn one horizontal line for my reference. This velocity makes an angle alpha with the horizontal line here. So, the same velocity with the horizontal line should continue to make the same angle alpha. And if that is alpha, this is going to be 90 minus alpha, because this line is perpendicular to this line. So, this angle is 90 minus alpha. So, right, I hope you understood this small simple geometry there. Now, you know very well that in a projectile motion, the horizontal velocity of the particle will always remain constant, because it is moving in the gravitational field, which has got an acceleration only in the vertically downward direction. So, I will just equate the two velocities in the horizontal direction. So, I will say 3 cos alpha is equal to 4 cos 90 minus alpha, which is nothing but 4 sin alpha, and that gives me tan alpha equal to 3 by 4. Tan alpha is equal to 3 by 4, or alpha is equal to, I think, 37 degrees. Alpha is 37 degrees. Now, I will give you the minimum kinetic energy, which is going to be just because of the particle's horizontal component of the velocity, which is still present with the particle when it is at the highest point. So, half mass of the particle is 2 kg and the horizontal component of the velocity of the particle is either 3 cos alpha or 4 sin alpha. I can use any one of them. So, I will use 3 cos alpha. So, 3 is 3 and cos alpha is going to be 4 by 5. Remember, cos of 37 is 4 by 5. So, it is 12 by 5 and half mv square, that gives you 144 by 25, and 144 by 25 is 25, say 5 are 125, fine, and I think that happens to be 5.76. So, D option is perfectly correct. So, this is the right answer. Of course, I did not go for dividing it completely here, but you can always cross check and verify, but it should be 5.76 joules. So, this is the minimum kinetic energy of the particle associated with the particle when it is at the highest point.